Here in problem number 13, we're asked to evaluate the value of an integral. F of x is defined as a piecewise function, and we could think of this problem two ways. We can work analytically, we'll do that first, or we could think of this one graphically. Let's start just by cranking out the steps. You see the rule splits when x equals 3, and the interval goes from 1 to 5 for integral. So we're going to split this up into two integrals. We're going to integrate from 1 to 3, and we're going to add to it the integral from 3 to 5. So what's the value, or what's our function defined as for the parts before x equals 3? No, that's the top piece. So we're going to have to integrate 2 with respect to x. No, I don't need that much space. We're going to send plus the integral from 3 to 5. Well, after x equals 3, our function is defined to be x minus 1. Now we can continue. If you integrate 2, we'll get 2x, and we'll evaluate this from x is 1 to x is 3. If you integrate x minus 1, we're going to get x squared over 2 minus x, evaluated from x equals 3 to x equals 5. So let's crank out the steps here. Fundamental theorem. We're going to have one value minus another value, plus the fundamental theorem again, one value minus another value. Remember, we're really talking about one quantity plus another quantity. So let's fill in the blanks here. Put in 3 in for x, 2 times 3 is 6. Put in 1 in for x, 2 times 1 is 2. Over here for the next quantity, put in a 5 in for x. 5 squared, 25 divided by 2 is 12.5. Oops, forgot something. 12.5 minus 5 is going to be 7.5. And we'll put 3 in for x. 3 squared is 9. 9 halves is 4.5. 4.5 minus 3 minus 1.5. Clean it up. 6 minus 2 is 4. Plus 7.5 minus 1.5 is 6. 4 plus 6 is 10. This matches option letter D. This is one approach. If you don't like this approach, we could sketch a graph and just find an area or two areas, put them together. Okay. So if you think of it like this, if you graph y equals 2, you're going to get some function like this. Here's y equals 2. But y equals 2 is only defined for the parts where x is less than 3. So we'd have to do something like this. 1, 2, 3, 4, 5. So for f of x, we're only going to look at y equals 2 for values where x is less than 3. Okay? Now let's look at x minus 1. You can have a straight line with a slope of 1. It goes through 0, negative 1. It's going to look like so. Here's a graph of y equals x minus 1. And this is only defined when x is greater than or equal to 3. So now you can see what our piecewise function looks like. Now to integrate from, what is it, 1 to 5? We just need to find some areas. No big deal. We'll cut this into two regions. Region 1 is a rectangle, or actually a square. And region 2 is a trapezoid. The area of the square is 2 times 2, or 4. The area of the trapezoid, let's see, that's going to be 1/2 times the sum of the bases. The bases are 2. Now let's think about this for a minute. When x equals 5, this function x minus 1, it'd be 5 minus 1. So this other base is length 4. And you can tell this interval is length of 2. So the base is 2. The times 1/2 times 2 eliminate each other. 2 plus 4 is 6. And 4 plus 6 gives us 10, the same answer we got analytically. So you can think of this two different ways. Either way, we get the same answer. Hopefully this video is helpful. Thank you for watching.